So we're talking about the new worker, which is happens to run on Kubernetes, but actually has advantages for all customers deploying to all targets. But I'm jumping ahead. Let's first start with who we are. So today we have Trent and myself, Kit. So we work in the same team. Our team is being here focused fully on Kubernetes, and all improvements are around Kubernetes. So Trent, do you want to say a couple of words about yourself?
No, but hi, Trent. I'm the lead developer on this Kubernetes worker piece that we've been doing for the last few months. It's going to be great to talk to you about it today. So I probably should just let Kit get back to it, and I'll talk to you later.
Yeah, I'm Kit. I'm product manager, so I work with Trent to figure out what we're building next. And I'm in Auckland. And hey, we have someone else in Auckland. Amazing, 7 a.m. here. Okay, so today we will talk about uh, the new worker and how to, why, how, what to do, and we'll show you how it works. So who would benefit the most from this talk? It's basically anyone who run Octopus and deployment infrastructure. So if you have problem like how I do deployments, where I find infrastructure for that, how I provide access and all this, that's definitely for you. But if you're just curious in how Octopus works and what it does, it's also for you. So while we present, please don't hesitate to ask questions in the chat. We will try to pick up a few and answer them straight away. Or if we don't have time, or if we like past the point, we will just talk about them later because our talk is approximately 45, 50 minutes, and we'll definitely have time for questions. All right. So what's on the agenda? So I'll talk about what is all for and high level how can you use it. Then I'll pass it to Trent, and Trent will dive like 5 levels deeper and explain you how exactly this thing works and why and how to use it. And then Trent show you a quick demo to just demonstrate how easy it is. And then we will talk about how you can try it when it's available and how you can give us feedback, which is the most important part of this final couple of slides. Okay, so why Kubernetes Worker? A few months ago, as you probably know, we released Kubernetes Agent, which is just a new way to connect to Kubernetes clusters. And while we were talking about this and presenting and publishing some articles, we had so many questions about why can't I just run any deployment task in Kubernetes and benefit from Kubernetes as a scalable platform? And indeed, I thought about it like, why not? So we spent some time building upon Kubernetes agent, and today we're presenting the worker, which is actually just a worker. So don't think about this as anything Kubernetes specific. It's literally a worker which can deploy to any target as any other worker, and the benefit of this is just scale, and it scales without you thinking about this, without any manual intervention, without any extra scripting. It's basically scalable worker out of the box. And it runs on Kubernetes just because it's easy to build auto-scalable, stable things on Kubernetes. So that's all it is about in a nutshell. The worker, as any other worker you have in Octopus, use our default worker tools. So when you install the worker, it will automatically deploy with our default worker container. And as usual, with any other worker, you can configure and supply your own execution container at the step level, but also you can actually change the default worker during the worker installation. And then you can create your own container, update this container as you wish, and the worker will just use it for all your deployments. So this is really neat, hopefully. Um, the worker is easy to install. You literally don't need to do anything except for just open the installation flow, copy two Helm commands, put in your CLI, and that's it. Octopus will actually generate commands for you. Or if you want to dive deeper, you can just download the Helm chart and play with it, change it, modify it as you wish, and use other tools like Terraform or anything you use to bootstrap your clusters. So it's your choice. Either go very light and spend just 30 seconds doing this, or go deep and fine tune it. You choose. Octopus also will maintain the worker. So what we will do, we run health checks and every few minutes. And through these health checks, Octopus will know if the worker is healthy, if there are any issues, and we will even do auto upgrades. So ideally, if you install it once, you don't need to do any maintenance. You can switch it off, by the way. But by default, Octopus will upgrade it for you and ensure it's healthy. At some point, there will be probably some breaking changes, but all the minor changes, you'll have them for free with zero effort. Finally, our new worker operates in the pull-in mode. That means that worker from Kubernetes cluster will connect to your server, and you don't have to install, configure anything like ingress on the Kubernetes side. This is to make it a little bit easier, but don't forget if you run Octopus server on Kubernetes, then you need to allow that. So this is a bit of extra configuration, which you're probably aware of anyway if you use any other workers already. Okay, and finally, migration. What if I use some workers on VM or some other workers and I want to move to the new worker? What should I do? Actually, not so much. As soon as you install the worker, you just add it to a worker pool as any other worker. And we recommend you removing other workers from this pool because Octopus will evenly distribute load and it will work. It's just a bit strange if you have one autoscalable powerful worker and a few other VMs and you will use them in like round robin. So remove other workers and just keep using this pool and Octopus will schedule tasks against this worker. So that's it. No need to change anything at step level. No need to change any other configuration. Just add the worker, add it to the pool, and it will run. All right. Now we're done with the intro part, and Trent, over to you. How does it actually work?
Hey, Kit, thank you very much for the handover. So just checking time, and it turns out that we've got lots of time, so I can talk to this for quite a while, but I'll try to keep it brief. So the first thing that's worth saying, and we've already touched on it, which is this new version of this Kubernetes worker, it is just our existing agent. We've just put a bit of extra work in there to allow it to operate as an Octopus worker as well. So when we look at the really high-level Kubernetes architecture, we've put an agent into the cluster, and it's long living, and it connects into Octopus, and it says, "Hi, I'm a worker. Please give me workloads." And so the Octopus server, when it's doing deployments or runbooks, will send those operations across to the worker in the same way we currently do by choosing the worker from the applicable worker pool. When that body of work gets to the cluster, the worker will spawn a new pod and pass that script work across to the pod. So you can imagine that if you're doing a really large deployment, you might have a bunch of steps running in parallel and lots of jobs are being sent to this worker. And every time that we get one of these jobs, we spawn a new pod. And as we spawn more pods, eventually the cluster says, "Hey, I'm full. I'm going to need to bring in additional nodes. So I've got more compute, more memory, and we can keep doing more and more work." Then as those deployments drop off, those pods will terminate and complete. And again, the cluster will say, "Hey, I've got all these nodes I don't need," and it can release them back again. And so obviously this is how we're leaning into that scaling aspect of it. Now, one little interesting piece of this is that we need to create a shared storage layer between the worker and these script pods, because Octopus is going to send over packages and binary blobs that those workers need. And so the worker receives them, puts them in the shared storage so that the other pods can access them. By default, we're using an NFS server, which appears to be working pretty well to date. But you can replace that with any persistence mechanism that you're happy with, which means I've probably spoken ahead of what my next slide is going to talk about.
Wait, while we're here, Trent, just a couple of questions. We tested a worker with a few parallel tasks. I think we end up with like 100 deployments running in parallel, and worker just was absolutely fine. Something like
Yes.
that.
Yep.
Nice.
We were doing some pretty crazy load testing to see how far we could push it. And we'll talk about that in a minute, but if you throw 100 scripts at a small cluster, it'll be fine. Now someone will hold me to that, so maybe I should have kept that a little less excited. But yeah, this it scales really nicely. And we'll actually go into that scaling in the demo as well.
We actually have a question from Ray in the chat. Oops. And Ray asked, like, is there a way to restrict how much is autoscale? Only scale to, for example, only scale up to 50 pods.
That is a terrifyingly good question. And unfortunately, at this stage, I don't have a good answer. Definitely worth us tracking that.
Yeah, that's a good question. Let's put it, Ray and others who might be interested. Can you just, I'll share the link at the end about like where to give feedback. That's a good piece of feedback. And if you can give us a use case of how would you do that? Why would you do that? That would be actually helpful. Doesn't look like it would be hard for us, but yeah, we'll consider this. Thanks.
Yeah, I was going to say there's a whole lot of Kubernetes configuration that I could probably cobble together to make it act like that, but it wouldn't be as obvious as that, which I think is actually a really cute idea. Yeah, awesome. Thanks, Ray. Moving onwards. So some of you may already be using our Kubernetes agent, and if you are, you're using that because you want to deploy software into your cluster. That's great. You can keep using it. And in fact, you can install workers next to it in their own namespaces doing their own thing. They can absolutely coexist on the same cluster, but you just need to appreciate that they have very different purposes. That the agent is there as a deployment target. It's saying, let me deploy things into this cluster for you. It has reasonably high privileges so that it can affect other namespaces, and that's its role in your infrastructure. The workers are not like that. The workers are just arbitrary workload executors. So you can have a number of them installed. For example, you may have them in different spaces, different teams using different workers. You may have one worker and everyone hitting the same place. But the worker is only able to operate within its own namespace. It's not going to reach out across your cluster. It's quite carefully permissioned so that it can't impact other people operating in this cluster. At this stage, there's no limitation to how many workers you can install in your cluster. You could install 3,000. But you just need to make sure that you maintain name uniqueness, even when you're dealing with like cross Octopus space concerns. So if one space has a worker called Dave and another space tries to create a Dave, you might run into some interesting problems at the moment, but there's work afoot to resolve that. Otherwise, you can install and destroy as many of these as you like.
It's not like you have a good reason to install multiple workers on a cluster, right? So, but you can do that.
If you had multiple teams working in different spaces in Octopus, you may want each team to have their own worker. So it's when you start dealing with the multi-space environments, maybe. But certainly in one space, I'd probably be leaning towards one. Autoscaling. Wow, autoscaling is simple and complex depending on how hard you want to look at it. So, like we said before, fundamentally, in a vanilla default environment, we really lean into the cluster autoscaler. So that is that each time we get a job, we put a pod in. Eventually, when there's enough pods, the last pod goes into pending and says, hey, there's no space for me in this cluster. The cluster will then say, oh, we've got someone pending. There really should be an extra node so that we can run this. So if there is the availability of another node, the cluster will bring in another node, the next node, and run that pod on the new node. Brilliant. This is auto-scaling. Love it. If you do not have the ability to add extra nodes to your cluster, then that pod will stay in pending and wait for one of the existing jobs to finish until there's enough resources to execute it. There's lots of options for managing your auto scaling. You can configure our pods to define how big or small they are, so that obviously puts more or less pressure on the cluster as you do work. You can look at things like Keter or Carpenter. They're a little more complex, but they give you lots of flexibility. This was actually covered really nicely in our K8's reliability webinar that Liam and Frank did about a week ago. They talked about this in depth. So if you need to learn more about autoscaling and how to make the most out of your worker, it's definitely something that's worth going to look at. But it's suffice to say, out of the box, your cluster will add nodes if they're available as we do more work, and it will then release them again afterwards.
Hey Trent, William is asking, so clarify to me one worker's deployment of one replica. It spawns additional job pods, or I'm totally wrong.
Perfect. So yes, our worker, that thin agent, is a deployment. So the pod itself may get destroyed, but the deployment will recreate it. Then each time Octopus says, please run a script, we'll spawn a very short-lived job pod to do that work. And once the work's complete, that pod will terminate and fall away again. So that is exactly what we're doing.
Right, let's
I
move on.
feel like there could be a follow-up conversation about that one, because that really strikes the heart of what we've done. But maybe we'll wait for the Q&A and we'll go from there. Okay, so jumping into our next slide, permissioning. Permissioning is interesting. So despite the fact that there's only 2 sections on this slide, there's 3 times that our permissions really need to be considered. So during install, we're installing with a Helm chart. We do lots of stuff in a given namespace, but we do create some persistent volumes and we do create some cluster roles, which means that you need to have elevated privileges to do the initial install. Then during runtime for the worker, we can't touch other namespaces. So every one of our pods is really low permission. It says, hey, I'm allowed to run here. I can affect this namespace, but I can't look outside of my namespace. So we really can't impact the other applications in the cluster. But the third one that is kind of worth considering is during our auto update. Now, obviously, an update is very similar to an installation. So when we do this update and we install a new Helm chart, we're probably going to need to make some more cluster resources, which means that our auto update process needs elevated permissions again. Now, why is that a problem? The short answer is it probably isn't a problem, but it is worth knowing and understanding. This is an automated update. This is a background service. And so when we run it, we need to affect the cluster. We need elevated privileges. But that account that we're doing that work with is not publicly accessible. It's only visible from within the Octopus server. So it is limited in time, but not in scope. Now that sounds kind of terrifying because you're letting someone else do an install into your cluster. And if that is a problem, you can disable the auto updates, which means that this process won't run. You will need to do your own manual upgrades, and Octopus will tell you when upgrades are available. This is the solution we've gone with for now. We'd love to get feedback around what people are comfortable or not comfortable with Octopus doing in that cluster. So, please, either in the Q&A session or on the roadmap or just hitting up our community Slack, it'd be great to hear what you're thinking about it. Kit, anything else that's worth mentioning on that one?
I just remember a conversation that at some point something should update the worker, and by default Octopus can do it, so that's why it has privileges. But yeah, you can definitely switch it off and choose other way to update the worker if you use something else to bootstrap your cluster, and that will also work. Just don't forget to switch the auto updates off on Octopus side. So, but at some point something will have to have access, so it's really hard to completely avoid this.
Beautiful. Where are we talking about next? Oh gosh, customizing Helm values. Okay, so when we go through our demonstration, this will become a little more clear. But when we install the worker, we set about 8 or 9 Helm values on the command line to specify the behavior that we want from our particular install. Now, the thing is that when I look at our Helm values, there's probably about 150 of them. And these Helm values are basically part of our public API. So we invite you to look through this values file and modify it as you see fit, because they'll all just tweak the behavior of the agent a little bit. I'd love to go into them all in depth, but the three that I think are worth quickly mentioning is the first one is what we call execution image. So obviously our worker is just a regular old Linux tentacle running in your cluster, but when it spawns the job pod, what image should that be? By default, we give you our worker tools. So that's great. That gives you all of your Azure, your Terraform, your Helm, your whatever you could, 90% of what you could probably need is already in that image. And you get that with zero configuration. But you may, by default, want those job pods to be running a completely different image with tooling of your own wishes. So at installation time or at any time via a command, a Helm command line, you can set those execution image flags so that all of our pods spawn with your image instead of the worker tools image. You don't need to do it, but if it's something that's important for your use case, go for it. The Helm values are all there for you. The second one that's worth mentioning is that we have our resource requests and limits for those job pods. So you can specify, hey, actually, I want my worker pods to, by on average default, for 10% CPU. At the moment, it's set for 2.5%, but maybe you need to bump it up. Maybe your workers are busy. You might want to set limits. You might want to say, actually, I don't want to give any of my job pods more than 10% of a CPU. So that's all exposed through our values file. The final one is the service account permissions, and this is the service account that our worker is running as and what permissions they have got. Again, we've set defaults to make it reasonably restricted, but if you need it to do more, or if you think that your script pods are going to do more, then you can override that if you need to. So all of this is documented in our Kubernetes agent Helm chart README, which is in its public repo. Thank you very much. Please go have a read. Again, if you've got any questions, hit us up. If there's something else that you'd like exposed, please let us know. That we think this is great, but we also know that once it gets out in the wild, new and crazy ideas are going to come in. So, let us know. We want to fix it. We want to do it. Where are we up to? Radio. Changing the execution image. So this is just a little example of what a Helm chart command could look like. Okay, so just working from top left to bottom right. We're going to do a Helm upgrade. We need to work in the namespace of your worker, and we want to affect the worker release. We're going to reuse the existing values, but I want to override the script pods.worker.image.repository. So that's really the image name, right? That's like Octopus deploy / worker tools. And you also need to override the image tag. So you might want to use latest, you might want to use 1.0. So if you ran that command in a terminal or in a web console attached to your Kubernetes cluster, you could change the default image that your script pods will be started up with. It looks horrifying, but I guess the more you play with Helm, the more you become au fait with these sort of command lines that are as long as your arm. So yeah. Kid, if you get excited, then please yell out. But awesome. So you can use this for any of our images. Obviously, you just need to change which values you're actually changing. Agent upgrade V1 to V2. Okay, so agent V1. Agent V1 is where it's just a deployment target, right? It didn't have any worker capes. V1, V2, we're talking about the version of the Helm chart. Sorry. So V1, it was just the deployment target. It had none of this worker capability. Then we went and put worker capability into it and went, we really should restructure our Helm chart, which means it's a V2. So it means that if you want to upgrade from V1 to V2, I'm really sorry, they're different shapes. If you want to do that, you're going to need to do a migration as you do that installation. At this stage, we don't have automated migrations. You do need to do it by hand. We have documented it. Automated migrations are coming up. At this stage, you do not need to upgrade. If you are on V1, V1 will continue to work. V1 will continue to be secure. Once we release automated migrations, we would recommend that you do go to V2, but for now you are entirely safe. And I suspect I'm going to have to keep moving because I am running out of time and I speak slowly. So anyway, that's the short story. V1, stay on it, you're safe. From now on, recommend everyone installs V2. Eventually your V1s will become V2. Limitations. Okay, so there's a few things that the worker simply cannot do, and I doubt that it will ever do it unless someone pushes us very hard. So one, it doesn't support Windows nodes, that when you run your worker, it will always try to spawn itself and spawn job nodes on job pods onto Linux nodes. We do not have Docker available. Doing Docker in Kubernetes is privileged, and we want to try to avoid it. And the last one that was worth mentioning was that if you are unlucky and you run into cross-space name collisions, you may find that some of your installations don't work quite the way you're hoping. It may not be immediately obvious, but hopefully that one will go away soon.
Another question from Francis actually in the chat. So, does it support both Linux and Windows workers? And it doesn't support Windows nodes. And as Trent said, we considered that. It's maybe a few months of work. So what we wanted to do is, to be brutally honest, it's all about like, are there a lot of use cases where people actually need that? And why would they need that? So if you need that, please tell us why and explain the use case. And yeah, we will definitely look into that as a like agent V2 or worker V2, but just we need to know more. Because for now we had, after like maybe a few months with the agent release and collecting feedback for the worker, we heard this maybe once, twice. So more content would be definitely very, very beneficial. So please let us know. And while we're here, before we go into the slides, the presentation, maybe you can answer another question. So this one was about the use case for the worker. We have 15 to 20 clusters and we have a number of namespaces, a number of workloads. Can we just use this worker which autoscale on a separate cluster? So yes, that was the use case. You absolutely can do that. That was the idea. If you don't want to run something on your end cluster, your destination cluster, there are, like both pros and cons. So if you run the agent, arguably you distribute the deployment load across all your clusters, and each cluster will have very little deployment to do. You solve a lot of problems with, for example, authentication. So you don't need to create an API target, you don't need to rotate secrets and everything. So that's the agent. However, if you're happy to do this, if you're happy to create Kubernetes API target, provide credentials so Octopus can access the target, then yeah, you can run it from one place, install the worker, and the worker will do deployments across like, we have customers with edge clusters and they have hundreds and some of them have thousands of them. So this is the solution for them. So yep, you can just deploy everything from one spot, from like ops, infra, or whatever you call this special cluster you have for deployments. Right. Another question is DIND a hard no? Or something that would be supported in the Helm chat, but we could add ourselves by bumping the precisions, making sure the Docker executable is present in the base image. Trent, do you want to ask the question about Docker and Docker?
I do not want to answer that because I don't think I have sufficient knowledge of the goals of what the original agent were. So Alistair Pitts, I believe he did a webinar on this a little while ago about the agent, and they were, and he was the lead on the original agent, and he made the explicit decision not to support Docker in Docker. That was my understanding, and I thought that was because we're not running in privileged mode. I don't know if privileged mode is available via our values. I can see that offering that flexibility would be very valuable, and effectively handing the risk across to the person doing it. So I think that's something that
Yeah,
we should do an investigation on. I wouldn't necessarily endorse it, but I'd be happy to leave the door open.
I think we can tweak the worker this way, right? It just actually risks. If you know what you're doing, probably it's fine. So okay, thank you. Let's take this comment with us.
Mm, mm. Gee, there's no such thing as an easy question, is there? Radio, I
Right, so
suspect I'm
let's
going to
jump
press.
into demo.
Yeah, I was going to say, I think the next slide's going to say do a demo. So let's do a demo. Excellent. Okay, so you are all now looking at an Octopus deploy window, and you can see that I already have a worker there called for webinar. But let's ignore him for a minute. Let's go and make a new worker so I can talk you through what's happening. So I'm going to just say add worker, add worker. Hey, there we go. And you can see that we normally just used to have Linux, Windows, and Mac. We've now got Kubernetes, and we are going to say, let's install a Kubernetes worker. And this is going to take us through a workflow that looks almost identical to our original agents workflow. So if you've seen that, this will look very familiar. So I'm going to give my worker a name, which is going to be the new worker. And I can now choose the worker pool that I want to add him to. So I could add him to my existing worker pool. Or if I wanted to, I could actually go and create a new worker pool at that stage. Now, when I press that, this is literally going to create the worker pool in Octopus. Okay, so at that moment that I click that worker pool now exists in Octopus. It's currently empty, but the container exists. And you can see it's immediately gone into our into the group of worker pools that this new worker is going to be a part of. We've also got some show advanced, and down here we can choose our storage class. So this leans back into what I was saying before about how our worker needs to have a shared storage mechanism to work with its script pods, its job pods. By default, if I leave this blank, we'll just be using an NFS. If I apparently I can type things in here to use other storage mechanisms such as Longhorn or Azure Files or other persistence mechanisms. For the case of this, let's stick with NFS, I think. So I'm going to press next. Now, it's going to take us through a few screens here, and they're going to give us some Helm commands. And so theoretically, you'd want to copy these commands and you would drop them into, you'd execute them in a terminal that's connected to your cluster. This works really nicely in like the AKS run command console. This all just works. It's already pre-connected. Life's great. I'm not going to do this because it's going to take a few more minutes than we've actually got time for. So let's leave that. But let's assume that's now been successfully executed. Press next. So here's the Helm command that's going to install our Octopus worker. And so you can see some fairly normal things in here. It's the server URL. It's the URL that the work's going to reach back over. Tells us the space that we're operating in, the name of the worker, the fact that we're operating in worker mode, the worker pool, a bearer token for initial registration communications only. That's short-lived. It only lasts for about an hour, I think, Kit. An hour sounds good.
Yeah, I think
And
it's exactly
otherwise,
our. And there is a doc on our website in the documentation. If you want to install workers, maybe at scale through some other mechanism, not Octopus UI, you can actually replace it with more long-living token and then reuse it multiple times to install the workers. But I think important to realize you actually don't need this token after the installation. So it's just for the installation. And later, the connection between the server and the worker will work using the different mechanism, different uh, yeah secrets.
yeah, we end up using the SSL certificates as per existing tentacles and workers and deployment targets. So this is all right. Now, again, this takes a few minutes. I don't have a few minutes. But if I cut and paste this and ran it in the terminal, eventually we'd see this blue bar turn green to say, hey, I found the worker. We've done a health check. Everything looks great. So that's what you will see, and I guarantee it. So let's say you do that. you come back here, we've now got a worker. So what does it look like? Well, it looks exactly the same as every other worker. It's got a name, it's enabled, it's got a worker pool, it's got a policy which dictates when it gets updated, for example. Under connectivity, it's slightly different here, that we're actually starting to show you some of those Kubernetes fields. Like it's a member of this namespace. This is the Helm release that it's in. And here's the Helm chart version that we've installed. So it's a worker. It looks like a worker. All aspects of Octopus will treat it just like a worker. Now, the fun part of the demo is that I've created a runbook to really stress out this worker that I've created. Now, it obviously works for deployment targets or runbooks. It doesn't really matter which way you go. Steps are steps. Workers are workers. So the script that I'm going to run is 20 steps in parallel. The first one is running a stress test on the CPU. The rest of them are just having a bit of a sleep. But I just want to be able to demonstrate how this is going to auto scale. So if I run that up, and I'm going to need to run it against one of my deployments. Let's run that. Now, while that's starting up, I'll flip across to this. So on the right, so this is using K9s, which is a bit like Lens, and it lets me sticky beak into my Kubernetes cluster. So on the right, you can see that we have the NFS pod, which is providing shared storage. You can see we have the Tentacle, which is that long-lived agent, and you can see we've got a bunch of scripts as well. So in total, we've got 22 pods, 2 pods that live forever and 20 pods that are short-lived. So these are all running up, and over here we should be able to see that the CPU usage on it. Oh, sorry, the right-hand side is pods, left-hand side is the number of physical nodes or virtual nodes in my Kubernetes cluster. And so you can see we've got 2 nodes. The memory is not too bad. Now, if we're lucky and if I've organized this well, we should see a new node popping up in here as this workload builds up. I can see that we've got a bunch of pending pods over here. So because there's one's pending, that should be saying to Kubernetes, hey, we need more resources. This isn't working. It's just a matter of if that pod turns up before I run out of words is really the problem. Sorry, that node turns up before I run out of words. It did, and it should, but nothing ever works when you're on camera. Excellent. The pre-rehearsed demo has done exactly as it demonstrated it would. Now, it does take a little bit of time for that node to come up. So you can see it's flagged as not ready. It'll get there, and hopefully it'll get ready before all of our pods actually terminate and finish. I should say that if I go back into Octopus and press cancel now, all of these pods will get terminated immediately, and your cluster will clean itself up. So if you've decided you've done something that you shouldn't have done, absolutely canceling will clean it all up nicely. That was a much shorter demo than I feared. So yeah, I think at that stage we can probably close up and answer any questions or whatever it is we do.
I'll actually have a few more slides, I think. Let me quickly go through them. So, how you can try the worker. So you can actually try it right now. It's in early access. Early access means that we still actually work on this. It's actually not a bad thing because we have the whole team looking into all the feedback and all the potential issues we find, and they fix them on the fly. So we, as a team, are really responsive through product board and through our community Slack and through our support, normal support process. So please don't hesitate. And yeah, that's why this feedback is really important. So literally, if you have some use cases which we didn't account for, let us know. We are in this mode that we trying to add things or fix things as fast as we can. You already can install the worker right now if you're a cloud customer. So it's there, it's available since I think last Wednesday-ish. So it's been a week. So just go there, click add button, and you'll see the worker. If you're a self-hosted customer, you need to wait just a little bit longer. I think it's about a week and a half, and we will have the new 24.3 release. You can update your hosted Octopus, and the worker will be there. So it's not so far away. And finally, if you want, it's maybe like sixth time we mentioned this, but the more the merrier. So if you want to give us feedback on the worker, please go and do it in our roadmap. Add a comment, let us know what you think, and it's really important because we actually change, update, improve the features based on this. If you want a longer conversation, just go and talk to us in our community Slack, where we have a lot of people from the team talking, answering questions, asking questions, and we can also invite you for an interview if you want to talk about the worker. Also, leave a comment either through roadmap or through in the community Slack, and we'll talk to you about this. So yeah, I think that's it. Thank you. And let's see if we have any more questions because I think we answered quite a few.
I think you guys are doing great. Thank you very much, Kent and Trent. Really appreciate it. I'll just wrap up with some reminders to folks here. So once again, just to be reminded, these are a lot of webinars that we're doing. You'll find these available up on octopus.com/webinars. So you should try and make this a homepage, if not a bookmark. We try and encourage people to remind folks that these things are happening. Our next one is scheduled for September 12th. In addition to that, we also have our YouTube channel, which you'll find by searching for Octopus Deploy up on YouTube. You can see we're actually live here, but we post all the recordings of each and every webinar that we record. So you'll find it there later today, shortly after this. You can see also the previous webinars that we've done around Kubernetes as well. So we've mentioned things like doing it at scale. The agent webinar is also listed here, et cetera, et cetera. So you'll find all of this available up on our YouTube channel, which is at this URL here. Again, make that a bookmark. In addition to that, we've mentioned many times our roadmap, which is at roadmap.octopus.com. There you'll find features that talk about what we're doing around Kubernetes, as well as other features as well. A really interesting feature or capability of our roadmap is seeing what's shipped in Octopus Cloud. So this kind of speaks to why a lot of customers like Octopus Cloud, because they tend to get features before everyone else, before self-hosted, etc. And so if you're wanting to see what's shipped, what is planned, as well as what is under consideration, check out our roadmap at roadmap.octopus.com. All right, let's jump back now to the questions. That's enough tap dancing from me. Ray's had a lot of great feedback, which is awesome. Francis, very interesting. Thanks. I don't think we have any other questions here, folks. So I think we'll wrap it up there. Trent, Kit, thank you very much. We really appreciate it. And thank you for joining us for today's webinar. We really appreciate it, your time and attention. And until next time, happy deployments, everyone. Take care.